Let's take a look here now at example number 5. Let's suppose that I have a function f that's continuous, and that if I wanted to find the area underneath this function from 2 to 7, I could calculate that area as 11 halves, or 5.5. Now, my goal in this question is to show that the function f takes on the value of 1.1. That is, it hits the y value of 1.1 at least once on the interval from 2 to 7. Okay, if you read that through and you're trying to comprehend that, that is a very weird question. First off, I don't know what the function is, right? I'm not told if this is a polynomial function, a trig function, a function with logarithms in it. Like, I have no idea what this function is. All I know is that the area under it from 2 to 7 is 11 over 2, and my goal is to show that it hits the y value of 1.1. Well, what if 1.1 here was the average y value? I mean, I don't know if it is, but what if it was? If this was the average y value, then I could definitely go back and say that by my mean value theorem for integrals, if my function was continuous, then I know there would have to be a number out there where I hit the average y. So one of the first things I might try to do here then is to say, why don't we just try to calculate what the average y value is? So let's see. I'll start off by saying that we calculate that the f average for this function would be 1 over, let's see, 7 minus 2 if I use my interval from 2 to 7, times the integral from 2 to 7 of my function. Now, fortunately, I actually know that this is going to be 1/5 times the area under this curve, which I was given as 11 halves. So if I crunch this out, this is going to be 11 over 10. Dividing by 10 just moves the decimal point back one. And 1.1 actually is the average value. So I know that the average value will be hit by the function somewhere as long as my function is continuous on this interval. Well, I'm told this is a continuous function. So I can see here that since f of x is continuous on the interval from 2 to 7, then by the mean value theorem for integrals, there must be a value of c in the interval from 2 to 7 such that f of c equals f average, but of course f average is 1.1. So there's got to be a value inside the interval from 2 to 7 where this actually comes out as 1.1. So my argument at this point is finished. Notice I didn't have to find what the value of c was. This sometimes is, again, something that consistently throws people off with like the mean value theorem, the intermediate value theorem, the extreme value theorem. All of these theorems are just telling us that a value exists. It doesn't tell us what the value is, but it guarantees that it's out there. So the mean value theorem for integrals here has guaranteed us that there is a value of x I could plug in that generates 1.1. I don't know what it is, I don't know where it is, but I know it's out there. And that's pretty good. Now, this whole section may seem a bit strange. Why have we decided to start to talk about the average value of a function? And as you see down here in this final note, the average value of a function and the mean value theorem for integrals are actually extremely powerful concepts that will help us to connect a lot of the different ideas that we've talked about in calculus thus far. And we'll summarize them in the next section in what we call the fundamental theorem of calculus.